Are you on a quest for incredible print detail and accuracy? Do you dream of 3D prints with almost no perceivable layers at a price you can actually afford? Well, you might be in the market for a Resin 3D printer. And in this primer, I'll walk you through the important differences between Resin and FDM 3D printing, as well as the important safety and operational considerations associated with this fascinating 3D printing technology. Let's get started. How's it going, guys? Angus here and welcome to the dungeon. This is the new messy workshop for Maker's Muse where I can safely run laser cutters, machining tools and Resin 3D printers. I have many Resin 3D printer reviews coming up on the channel, and I figured instead of repeating myself every single review, I would make this one video covering all the important shared points so the reviews can be done concise and focus on the machine itself, not just the technology in general. So, why is this a big deal? Well, despite being the first 3D printing technology ever invented, Resin 3D printers are only just now becoming popular among hobbyists due to the affordable prices and small form factors. There are several branches of Resin 3D printer technology, but stereolithography was the first. In an SLA 3D printer, a vat is filled with a photopolymer which polymerizes at a specific wavelength. Put simply, it hardens when hit with UV light, and in an SLA system, the light source is a laser. There are top-down SLA systems where the laser hits the top of the resin bath, and bottom-up, where the laser goes through a clear bottom film into the resin vat to harden the resin, and the print magically grows out of it. As an example of bottom-up SLA is the Form 2, which I reviewed back in 2017, and this immense machine produced by Shining 3D in China is a top-down SLA. And then there's DLP, or direct light processing, which focuses a projector image tightly to cure an entire layer of a print at once and can similarly be built either with a top-down or bottom-up approach. And then there's the technology these bad boys behind me use, and the real reason that Resin 3D printers have become just so affordable and accessible these days, instead of a laser or bulky projector to provide the UV light source, they use a high wattage UV LED and an LCD screen to selectively mask off the areas that UV light is allowed through to harden the resin in that area. Although functionally similar to DLP, this technology is widely known as masked SLA or MSLA, and if you're in the market for a beginner resin printer, you're most likely going to end up with one of these. Okay, that's a very simplified description of the technology, so what should you keep in mind when purchasing a Resin 3D printer? First and foremost, safety. You will hear a great deal of conflicting information on the internet regarding this, so I'll preface this by saying I am no expert in the effects of UV resin, but this stuff commands respect and does pose health risks if the MSDS is to be believed. To operate these machines, you need to handle both the liquid resin and printed parts, so nitrile gloves, safety glasses, and appropriate clothing is a must. Believe me, the resin gets everywhere. You will also go through an obscene amount of paper towels and isopropyl alcohol when cleaning excess resin off prints before curing, which can be done in the sun or by using a purpose-built curing box with an evenly distributed UV light source. Once correctly cured, the prints are smooth to the touch and completely safe to handle if they have been indeed cured correctly. The resins also smell, ranging from barely noticeable to quite acrid, and I cannot at all recommend working in the same area as one of these machines. This is a blanket statement for sure. Not all resins and not all Resin 3D printers are made the same, but it's definitely a good idea to employ care here. You shouldn't work in the same room as any 3D printer in my opinion anyway. That includes FDM and FFF, so don't work in the same room as these. And well, not all resins are usable on these machines either, so be sure to check out what wavelength your machine requires for curing and recommended exposure times. Spills are a certainty, so I like to work on these thick plastic drop sheets which protects my concrete workshop floor. At no point ever should any of these byproducts be disposed of down the drain, as it poses a significant risk to aquatic life. Please be responsible and contact your local waste disposal depot and ask them how to safely dispose of your waste products when running these machines. One final point before talking about desirable features is the fact that, well, the resin is the same color whether it's cured or not, and on occasion the prints will fail to adhere to the print plate and instead stick to the FEP film, that clear film at the bottom of the printer. And look, that film is a consumable, it gets scratched and damaged over time, But should you try and start a print with hardened resin parts already in the vat, you will crush and destroy the delicate LCD screen below, and the process of filtering out the resin and ensuring no hardened parts remain after a failed print is incredibly messy and tedious. But if you suspect that there's debris floating in the resin, I still think you should filter it through a coffee filter and go through that process, because it's really messy, yes, but it's a small price to pay for completely ruining your LCD screen if there's any hardened resin in that resin vat. Alrighty, onto usability. These entry-level MSLA machines behind me all have a similar print volume, but their build quality and features vary wildly. Frame construction might be injection molded plastic or sheet metal for more durability. The cover might simply sit in place, or it might hinge out of the way for easy access. Resin printers use different slicers to FDM, FFF 3D printers, and some machines have basic USB stick connectivity, whereas others might work over Wi-Fi. The high power UV LEDs get quite hot, so these machines often have quite loud exhaust fans, which can also bring the smell of the resin out into the room even more. But some manufacturers will take this opportunity to fit a filter to try and mitigate this. In Resin 3D printers, the only moving axis is in the Z direction, so high quality and rigid mechanical design is critical to help prevent layer inaccuracies. This also means leveling is incredibly important, because prints won't adhere to the print plate if the bed is misaligned or too far away from that first layer, and too close again, it could damage the LCD screen. Some machines come from the factory completely pre-calibrated and ready to go, while others require you to go through the calibration process yourself, and you will need to recalibrate periodically as you use these printers. So there you go, my primer for Resin 3D printers for beginners. And if you think Resin 3D printing is a technology for you, you can find my playlist here of all of my Resin 3D printer reviews, and that list will be growing very quickly as I review these machines very shortly, and I've also got some coming in the future. So if you don't want to miss those, be sure to subscribe to Make This Muse, where it's my aim to empower your creativity through technology. And I look forward to seeing you again very shortly. Catch you later, guys. Bye.